Hi everyone. So let me discuss important concept, that is continuous function. So definition of continuous function is a function f of x is defined in a neighborhood of a is said to be continuous at a point x is equal to a if limit extends to a f of x is equal to value of that function at the point a. So another definition of this is a function f of x is said to be continuous at x is equal to a if given epsilon greater than 0 there exists a corresponding delta greater than 0 such that modulus of f of x minus f of a is less than epsilon. So this can be written as limit extends to a f of x is equal to f of a. So this is of the form epsilon delta definition of continuous epsilon delta definition for continuous function. So that is of the form using the function f of x is said to be continuous at the point x is equal to a if for given epsilon greater than 0 there exists a corresponding delta greater than 0 such that modulus of f of x minus f of a is less than epsilon whenever modulus of x minus a is less than delta. So note for this is a function f of x is continuous at x is equal to a if left hand limit, right hand limit and value of the function should be equal. When a function is said to be continuous if left hand limit, right hand limit and value of the function should be equal. So another note is if a function is not continuous at a point, then it is said to be discontinuous at that point. A function f of x is discontinuous at the point x is equal to a if limit extends to a f of x is not equal to value of the function, that is f of a. So another definition for this is equivalency. If f of x is discontinuous at the point x is equal to a if any one of the following condition hold. So that is left hand limit does not exist, right hand limit does not exist, or limit extends to a f of x is equal to limit extends to a to the power minus f of x and value of the function doesn't equal. If these two equal and value of the function doesn't equal, then also the function is discontinuous. Or if these 2 points not equal. And another point is limit extends to minus a f of x is equal to left hand limit doesn't equal to value of the function, or right hand limit doesn't equal to value of the function, then the function becomes discontinuous at that point. So another definition for this is a function f of x is said to be continuous in an interval if it is continuous at every point in that interval. If the function is continuous at every point in the interval, then the function is said to be continuous in that interval. A function f of x is said to be continuous in an open interval ab if limit extends to c f of x is equal to f of c for all c belongs to ab. So means in that open interval it should be means the function should be continuous at every point. Okay, so then that becomes continuous at that point. A function f of x is continuous in the closed interval ab if limit extends to c f of x is equal to f of c for all c belongs to ab. So this can be written as limit right hand limit is equal to value of the function and left hand limit is equal to value of the function. So that is at that point b. Geometrically interpreted, a function f of x is continuous at x is equal to a if the graph of the function y is equal to f of x has no breakpoint at x is equal to a. So if you plot a graph and if you draw a line, so the function should be shouldn't have no break. So then we can say it is continuous at that point. Okay. So here I take example. So that is show that f of x is equal to minus x square and x is less when x is less than or equal to 0, then you get the function is minus x square, and if x is strictly greater than 0 you get x square. So this function is continuous at the point x is equal to 0. So we have to show that. So here I take left hand limit is equal to limit x tends to 0, so that is minus x square. Okay, so substitute the value, that is s tends to 0, limit s tends to 0, then it will become minus of 0 minus h whole square. So then it will, if you substitute h tends to 0, then it will become 0. So means your left hand limit becomes 0. So now we check right hand limit. So limit x tends to 0, f of x is equal to limit x tends to 0, x square. You know that f of x is, for positive values x square, for negative values it is minus x square. Okay, so then you substitute 0 plus h, limit h tends to 0, 0 plus h, x is equal to 0 plus h. So because your x is equal to 0, so it will become 0 plus h whole square. So when h tends to 0, then it will become 0. So therefore your here you found the value of left hand limit and right hand limit. So therefore from equation 1 and 2 we can say limit x tends to 0, f of x is equal to 0. So if I substitute for any value, these two value, so your f of 0 means value of the function f at the point 0 becomes 0. So here your left hand limit, right hand limit and the value of the function becomes 0. Therefore the function limit x tends to 0, f of x is equal to f of 0. So that is equal to what? 0. From equation 3 and 4 we can deduce this as 0. Therefore the function f of x is continuous at the point x is equal to a. So another example for this is, show that the function f of x is equal to sin x by x plus cos x when x is not equal to 0 and 2 when x is equal to 0. So here left hand limit, so that is limit x tends to 0, f of x is equal to limit x tends to 0. I am substituting here the value of the function, that is sin x by x plus cos x. Okay, so here, so limit h tends to 0, so this is left hand limit. So here your value becomes x minus h. So and you know that x is equal to 0. Continue. So sin 0 minus h divided by 0 minus h, this is cos 0 minus h. Okay, so limit h tends to 0, sin minus h divided by minus h plus cos of minus h. So this is a standard result is there. So that is minus sin of minus h is minus sin h. So minus divided minus so plus. So limit h theta tends to 0, sin theta by theta is 1. So this will become limit h tends to 0, sin h by h is what? 1. And you know that cos h tends to 0 is sin limit h tends to 0 cos h. So when cos 0 is what? 1. So therefore 1 plus 1 is what? 2. So this is the left hand limit of the function, and I take it as equation number 1. So now we check the right hand limit. So that is limit x tends to 0, sin x by x plus cos x is equal to, so here x plus h. So your x is what? 0. So sin 0 plus h divided by 0 plus h plus cos 0 plus h. Okay, so it will become sin limit h tends to 0, sin h by h plus cos h. So limit h tends to 0, sin h by h is what? 1, and limit h tends to 0 cos h. So then it will become cos 0. Cos 0 is what? 1. So this is equal to 2. So here also we found the right hand limit. So your left hand limit and right hand limit both are equal. Therefore here I write limit x tends to 0, f of x is equal to what? 2. So now let me check the value of the function. So when but limit x tends to 0, f of x is equal to f of 2, and your f of 2 is what? 2. When your x is equal to 0, your x is equal to 0, f of 2 is what? 2. F of 2 is what? 2. So therefore from 3 and 4 we can say limit x tends to 0, f of x is equal to f of 2. So therefore here your left hand limit, right hand limit and value of the function all are equal. Therefore the function is continuous at x is equal to 0. So another example. So here show that f of x is equal to 4x plus 3 when x is less than 4 and 3x is plus 7 when x is greater than or equal to 7 is continuous at x is equal to 4. So left hand limit, f of x is equal to So this is 4. Okay, so limit x tends to 4, f of x is equal to 4x plus 3. So this can be expressed as, so you know that x is equal to 4, so this is x plus x minus h. So limit h tends to 0, 4 into x minus h, you know that x is 4, so 4 minus h plus 3. So limit h tends to 0, so if you this is 4 into 4, 16 minus 4h plus 3. So if you substitute this value, then it will get 4h means 0, 16 plus 3 is 19. So here your left hand limit is what? 19. So now let me check right hand limit, that is limit x tends to 4x is equal to limit x tends to 4, 3x plus 7. So when h tends to 0, limit h tends to 0, this will become 4 plus h, x plus h. So your x is what? 4. 3 into 4 plus h plus 7. So this is equal to limit h tends to 0, 12 plus 3h plus 7. So when your h is 0, so if you substitute the value limit, then it will become 12 plus 3 into 0 is 0 plus 7. 12 plus 7 is 19. That is right hand limit. So here your left hand limit and right hand limit both are equal. Then we can write from equation 1 and 2, limit x tends to 4, f of x is equal to 19. So now let me check. So value of the function, that is f of 4. Okay, so f of 4, so any value from here or here, you substitute 4, x is equal to 4, then you will get 19. So 3 into 4, here I am taking 3x plus 7, so that is 3 into 4 plus 7, so then it will become 19. So if you substitute here also, here also, then also you get 4 into 4, 16 plus 3, 19. So therefore here your left hand limit, right hand limit and value of the function are equal. So therefore I can write here limit x tends to 4, f of x is equal to f of 4 is equal to 19. So therefore the function f of x is continuous at x is equal to 4. So this is the solution of the above example. So use in the similar manner you try to solve this example. Prove that f of x is equal to 3x minus 2 when x is less than or equal to 0 and x plus 1 when x is greater than 0 is continuous at x is equal to 0. So you solve this example. This is a homework example for you. So if you have any doubts regarding any examples or definition, you can send questions to my WhatsApp number and clarify your doubts.